All right, this is test review 2 on logs and exponential functions uh, over chapter 5. So let's look at number 1. The position of a particle moving on the x-axis is given by our x of t position function, 2t over e to the t. So part A says show that velocity is equal to 2 minus 2t over e to the t. So if we look at this, we just have to get from this position to this velocity function. And if you look at this numerator and denominator portion, that means that we have to go through quotient rule to get to the derivative. So we do f prime g minus fg prime all over g squared. So f prime, the numerator's derivative is 2 times the denominator e to the t minus the original numerator 2t times the denominator's derivative, which is e to the t, all over the denominator square. So e to the t squared is the same thing as e to the 2t, because those two exponents are next to each other. We just multiply them together. Right? So we have this so far. We want this to look like what this factored form. So I can take the factor out the e to the t. Once I do that, I'm left with 2 minus 2t. One of the e to the t's will cancel out between numerator and denominator, so I'm left with 2 minus 2t over e to the t. That matches our velocity function, so we have the correct one. Okay, part B, show that our acceleration is 2t minus 4 over e to the t. So again, let's look at our velocity function, see what rule we can use to get to the acceleration function. And again, numerator and denominator, so we have to go through quotient rule. So f prime g, so derivative of 2 minus 2t is negative 2 times the denominator minus the numerator times denominator's derivative. So e to the t's derivative is simply e to the t all over the denominator squared. So again, e to the 2t. Factor out the e to the t. I'm left with negative 2 minus 2 plus 2t. This gives me 2t minus 4 in the parentheses. And one of the e to the t's will cancel out, leaving us with e to the t in the denominator. So 2t minus 4 over e to the t matches with our acceleration function. Okay, part C. For what value of t is the particle at rest? Now, particle is at rest when velocity is 0. So we can simply look at our velocity function, set that equal to 0. Numerator, so basically when velocity is 0, that's when numerator is 0. So set 2 minus 2t equal to 0, and we solve for t, we get t equals 1. So when t is at 1 second or 1 unit, we know that the particle is not moving. For D, for the value found in part C, which is t equals 1, is the particle located to the right or to the left of the origin? So we can basically, we want to compare the position of this particle with the origin. So I can simply plug 1 into the position function. So 2 times 1 is 2 over e to the 1, which is e. So 2 over e, this is basically 2 over 2.7, which is going to be a value that's less than 1, but still greater than 0. So we know the particle will be located to the right of the origin because 2 over e is a positive value greater than 0, to the right of 0. Okay, for E, for the same value from part C, is the velocity increasing or decreasing? Now, this is not saying whether the velocity is positive or negative. It's asking for, is the velocity increasing or decreasing? So this is asking about the rate of change of velocity. And the rate of change of velocity is basically acceleration. So in other words, is acceleration positive or negative at t equals 1? Because that's the value from part C. So if we can plug 1 into the acceleration function, then we can determine whether it's positive or negative. So if I plug 1 into acceleration, which is 2t minus 4 over e to the t, plug 1 in for t, I get 2 minus 4, which is negative 2. So negative 2 over e to the first power is negative 2 over e. Now this is negative, which is less than 0. We have a negative acceleration, so negative acceleration means velocity is decreasing. Okay, for what value is acceleration equal to 0? So we want to figure out when acceleration is equal to 0. So we set the numerator of acceleration equal to 0. 2t minus 4 equals 0. Solve for t, we get t equals 2 seconds. So what is the velocity when acceleration is 0? Well, we know the acceleration is 0 at t equals 2. So the velocity at this moment in time, we simply plug 2 into the velocity function. So v of 2 is 2 minus 4 over e squared. We're simply plugging 2 into the velocity function. So 2 minus 2 times 2, which is 4. So 2 minus 4 is negative 2 over e squared. At t equals 3, is the velocity of the particle increasing or decreasing? So again, velocity of the particle is talking about acceleration. So plug 3 into the acceleration, and we see we get a positive value, which means that velocity is increasing at that moment in time. At t equals 3, is the speed of the particle increasing or decreasing? So if we recall, speed of the particle increasing, decreasing, this means we have to compare signs between acceleration and velocity. Velocity at 3, let's find velocity at 3. So plug 3 into the velocity function. We get 2 minus 6 over e cubed, which is negative 4 over e cubed. Now this is a negative value. Acceleration is a positive value. So at 3, we have positive acceleration and negative velocity. So because opposite signs between velocity and acceleration, we know the speed is going to be decreasing at t is equal to 3. For J, for what value is the particle located at the origin? So the origin is where x of t is 0. So we plug 0, replace x of t with 0, and we simply solve for t. So the position function is 2t over e to the t. Position of 0, and if I do cross product, I get 2t is equal to 0, so t is equal to 0. So that is the time when the particle is at the origin.